So I just want to go ahead, I'm just going to jump right into the demo here. I'm going to open just a basic part that I made for this demo. So I'm going to do just some basic turning with a multi-channel machine, just doing some simple turning, simple milling. I want to showcase the sync marks. So what I'm going to do as a CAM programmer is I'm going to start a brand new file off of this design file. So I can do intrametric. I've got this out of the box. I'm going to do everything out of the box here. So all this stuff is, everything you see is what you would get with NX. No customization needed here. So I've got this multi-channel simulation machine here that I'll do. All right, so we're going to open that up. That's going to bring that whole machine assembly in, the whole machine environment in, as an assembly inside NX. So we'll take a look at what that looks like here. All right, so that's just all of these components here that it's brought in for us. So it's brought in our part, a lower turret it has on here, an upper head. This would be like a B-axis if you're familiar with anything like that. So the first thing I'm going to do is just go ahead and position the part here. So I'm going to move this component here into place. I'm going to move it to the chuck, and I can use, we've got a number of really great assembly constraint tools that we can use to move it. I'll just move it close to the vice jaw here. But there are a number of assembly constraints that I could use to quickly snap this into place too. So there's some constraints and joints and couplers, things like that, that are really cool, really easy to use. So once I get that in place, I'm going to wavelength this. This is just a way to create this master model as an associative copy. So in case I need to make any edits, I can do that without disrupting the main model from the design team here. So as you can see, I've got two different files open here. So I'll just turn that component off, and now I'm just working with that linked body, that associative copy of that part now. Once we have that in place, what I'm going to do is in my manufacturing environment here, I'm going to set up my geometry. This is kind of what I call the foundation work. So we're going to set some things up. We're going to put some things in place ahead of time so that we don't have to do it later or inside of every operation. I'm just going to get this foundation work done first. So it inherits a lot of this information into each operation for me. And when I say operation, I mean each individual tool path. So I'll just get rid of this. We don't really need that. So I'm going to look at these items throughout here. I've even got these three operations that come in automatically. Again, this stuff came in with this machine environment. This is all built out of the box for this. And this is what, how we make the machine operate properly. So let's go through these steps, this foundation work. We've got this main spindle node here. This is just going to be our absolute work coordinate system, our X0, Y0, Z0, whatever, for the absolute position on your machine. So we'll just place that on the front of the part. And then we're going to define what the work piece is, what our finished part that we're working with is, along with our raw stock, our billet, our blank, whatever you want to call that, your casting, whatever it is. And I can make just a simple, quick bounding cylinder around this and just modify the size of it here. So once I've got that part, that blank set up, I can do check geometry as well, just to stay away from things. You can define that as well. So I've got that set up. I really don't need to see this anymore. I can just quickly hide that out of the way. I just need that for definition, for toolpath definitions. We've also got something unique to NX called our spun outline. So this spun outline here is automatically set up based on what part you defined, or you can define it yourself. But when you define it off the part, it automatically does it for you. And it's just a 2D representation of what that part is going to look like as it's spinning inside this chuck. So if you've got some oblong feature, or in this case, we've got this hex on here, I don't want to turn it down to a diameter down here. I want to turn it as it's spinning, right? What's that overall diameter of it spinning? So that's a really cool feature that NX has as well. And then how do I want to get from the home position where it loads tools or changes tool positions to a start point for our turning operation? So we have these avoidances that we can set up. So I can quickly set up these avoidances, and I'm just going to tell it to, I want to tell it to come to this position right around in this area. You know, just wrap it down to this point before you start cutting anything. From here you can go to your entry moves. So we can just set some of these things up really quickly like that. So that's all set up for us now. So why don't we go ahead and create I'm just going to do a simple facing operation first on this part. So we want to face the front of this off. We're going to need a tool for that first, right? So let's go to, we're going to just create a tool. And we've got a number of different tool types in here. We're going to do a turning tool. And I'm just going to do this simple OD tool. Let me go through the machine tool view here. I'm going to show you some of the things we've got on this lower turret and overhead here too. So let me expand all this and show you this first. So in here, these are all the different tool magazine pockets we put tools inside of for this upper head to grab the tools out of, or even on this lower turret, we've got different pockets and different tool holders down here, such as this radial mill holder here. Here's another radial mill holder. We've got this axial mill holder with a couple of different pockets. You can put it on the front or the back. We've got this little tailstock. We're not really going to use this tailstock, so I can just delete that out. We can get rid of that. A turning holder, this duo holder. If you want more devices, you know, we can just add devices in here rather quickly. We can create a tool and put it in pocket number 8. Should be one of these down in here. I can retrieve a device and grab a tool holder. These are tool holders, again, out of the box in this kit. I can grab that, another duo holder if I wanted to, and just place that in there. It's just going to put it in all these mount junction points, and it's going to automatically put it in the right spot. So now let's create a tool, and I'll put it inside of pocket 1 of this duo turn holder here. This one here is where I'm going to put it. Pocket 1. We'll name it. We can name this tool something. We'll name it something like a lower turret CNMG 432, something like that. So we can put that in here. All right, and it's loading up here, and it's going to put in this this tooling block, but I've actually got a tooling block in here already. I really don't need that adapter on there. I can just get rid of that. The next thing I want to do is I'm going to make the holder, how it's going to be placed in the holder down here. So I'll adjust that down 90 degrees. It's facing the wrong way. I'll set my insert to underside, so it's a left-handed on the underside here. So that should work out just fine. Now as I place this in here, I actually have to make an adjustment to put it in the right spot, the right mounting point. In this kit, it doesn't have the, you know, it's got some other position on it. I know the numbers off the top of my head. I just need to flip these. I think it's 150 and minus 50. And that'll just place it into that holder at the right spot now. So it's along this center line. Everything's good there. All right, so we can do that. We could also, if we wanted to do an upper head CNMG, we could do that as well. Let me create another one in pocket 1 of the tool magazine for this CNMG. I'll call this one upper head CNMG 432. Now this one's slightly different. I want to make sure that I have this one oriented the way that the upper head retrieves it from the tool magazine, which this is oriented correctly then. Everything's set up correctly on this one. So I'll keep the adapter as well, just as a, you know, how it's going to insert into this upper head here. So I can just select OK to that one. Now that tool is going to be in here as well. So we've got those two tools set up. Let's go ahead and do a facing operation with one of those. So I'm going to create an operation now. I'm going to create a tool path, and we just have a few different type of operations throughout here that you can choose from. As you hover over them, they tell you a little bit about what they do. They have good representation visually of what they're doing, and the dialogues are telling you what it does. So we're going to start with a facing operation, and we're going to set up these 4 different parents here. We're just going to give it some of these random things in here. These are some of the information that it's going to inherit in for us. So for example, this method, this lathe method, What this is telling it is it's going to leave 0 stock on the diameter and on the faces. I can create other ones to inherit information differently, and we'll do that later here in just a second. So for this operation, these Explorer dialog boxes is where we fill in our data of how we want to cut this. So the first thing I typically like to do for this upper head is come to the tool orientation. If you remember, we put it in the way that it retrieves it from the tool magazine. So we want to take this guy and rotate this up to where we will actually want to cut it. So we'll go all the way up to 90. So we want to face it this way. So we just fix that over. Now in the main tab, we're just going to set a distance, an axial trim plane. We just want to stop at 0. So we can just generate that toolpath. There we go. We've got a nice quick little toolpath here facing this part. Let me do this. I'm going to hide this sheet metal back here so we can see that toolpath a little bit easier this way. There we go. We can see that a little better now. So the yellow, this 2D yellow representation is what material has been left behind for us. There is a green here that's sort of hard to see, but that's what it cut on this operation. That's the stock it cut away. So there's our nice little facing operation to start with. Now the next thing I'm going to do is let's go ahead and create a pinch turning operation. The pinch turning is really cool in NX. It'll do all the sync marks for you, but as we do some other operations, we'll manually put in sync marks so we can make sure that certain operations run first. So the sync marks are really cool in the pinch turning. So let's go ahead and do that now. I'm going to go ahead and create another operation we have an operation here, rough turn multi-channel. So if you have a simulation kit set up, you get this operation, rough turn multi-channel. We're going to go ahead and do that one. Actually, first, I told you I'd mess with this method here. Let's do that first. I'm going to go ahead and we can create another method if we want. We could do this inside the operation itself, but I could do a method that will inherit information for me as well. So I can tell it how much stock do I want to leave on the face every time I use this method in an operation. So I'll tell it 100 microns and 500 microns, for example. I think that's about, I don't know, 4 thousandths and 20 thousandths, I think, something like that. So now when I create any operation, I can always use that rough turning as a method. It'll automatically leave that stock. Again, I could have just done that in the operation itself, but it's nice to be able to just inherit that stuff very easily. So for the pinch turning here, we're going to use the upper head tool. I'm going to go ahead and flip over to the tool settings. I'm going to go ahead and flip that up on our 90 degree orientation. And back on our main tab, I'm going to set an axial trim plane again. I'm going to tell it I want to be able to come through and turn all the way back to, close to the jaws. I want to be able to go to about there. I want it to stop here though. It can't go any further. No matter where it is, it can't go any further than this. All right, so now we set our multi-channel functionality. So we're going to merge 2 toolpaths together. We're going to set it to merge, and we're going to set our secondary tool is going to be our lower turret tool. And then we tell it how we're going to lead the main tool versus the second tool. So the mode, we can do it by distance, time, or revolutions, either one of any of those 3 options. We'll do it by a distance we'll do by 3 millimeters just so we can see it pretty easily. That should work just fine. So I'll generate that. There's our 2 toolpaths running on the top and on the bottom for our 2 toolpaths. We can see we've got 2 toolpaths up here. Right here, let's make this depth of cut a little bit bigger just to conserve a little time too. So we'll go 8 millimeters with that. All right, so there's the pinch turning. And when we get into the sync manager side, I'll show you where those sync marks are. But for now, let's go ahead and finish programming this part all the way out. Shouldn't take us but a couple minutes here. The next thing I want to do, I roughed this and I've got stock on this part, so now I want to finish it. I could finish it with the same tool, or I could create another tool. Let's talk about how we want to process this part. So my plan is I'm going to make another tool to finish the OD, and then I'll make an end mill to cut this hex, I'll make a drill to drill all these holes around the outside of it, and then I'll cut this pocket, and that'll complete the part. All right, so we're going to do, let's go ahead and create some tools for that. We'll create maybe a 55-degree. We'll put that in pocket 2. I'll call this a DNMG 432. Once you create a tool like this, though, you can come down here to your library and you can just export the tool to the library. I'll pull in a tool from the library here shortly as well. And it works just like we pulled that device in down here. It'll work the same way. So I'll do that here in just a second as well. All right, so there's the DNMG tool for finishing it. Now I'll make a, get rid of that one, an end mill to cut this hex. So we'll create another tool. I'll put that in pocket 3. I'm going to change to the end mill type tools, all these different milling type tools we have in here. So we'll set this, let me measure this radius. Okay, so it looks like I can get away with a 12mm end mill. Should do just fine for that then. So I'll create a 12mm end mill. All right, and we just fill out these variables throughout here. If we've got a lower radius, we could put that in. I'm just going to leave it as a square corner, but all these different variables, taper types, we got this legend up here to show you what you're filling in. So all these different things in here you can fill out. If you wanted a relief diameter, you can put that in, so you can see that we've got a relief on there, and then you can add a shank to it, for example. Go back to 12mm, things like that. We can put a holder on this. If we had an actual milling holder, we could put that on here. If you had a solid body, you could create it from a solid body, or you could fill in the parametric values yourself here. Or again, I'll show you where we can pull it in from a library here. So these are all out-of-the-box libraries that we can just pull straight in, and we can look at these different holders on here. So we've got a number of different out-of-the-box holders here. I'll just grab this top one here. And then we tell it how far that tool is inserted into the holder. So we're inserted 50mm. So there's our representation of that tool now. Let's see, what else do we need? I think we just need a drill. So we'll do one more tool, and I'll retrieve this one from the library, and we're going to put this in this radial holder here. So we'll retrieve a tool. We'll do a drilling tool. And we can look in here and see, let's see what size we've got here. Okay, 6.35, what is it? I think that's a 1/4 inch then. So we could get a 1/4 inch tool from our inch library if we wanted to, and we can tell it 1/4 inch diameter and find those tools, or we can find the metric tool and we can say, you know, I may not have a 6.35 if I look at my matches, I don't have any, but I could say, well, then find me anything between 6 and 7mm. Count the matches, there's 72 of those. So I can look in here and I can see all the tools that are between 6 and 7mm. So we can see all these tools here. 6.1, 6.2. We'll just use this generic 6mm. And that'll put it right inside of this turret, the holder here. And if you decided you put it in the wrong spot, okay, simple enough. We're just going to drag and drop it into the different holder here. We're going to put it up here instead. So you just drag and drop it. All those things are pretty easy to do. So now that we've got all of our tooling set up, we're going to go ahead and finish out this part here. So let's start with another operation, a turning operation for finish turning. And we'll use the DNMG to finish that out. And we'll use that lathe method to take it right to zeros. No stock left on them. All right, so again, I'm going to go ahead and go to the tool settings to adjust my value here to 90. There we go. And then we're going to set an axial trim plane again. We're going to tell it to stop right about here. You can put a nominal value too if you want, but I just use that quick visual point there. And we just simply generate that, and there's our turning operation running through there. There we go. All right, now we'll get into the milling side of things, and we'll go ahead and mill this hex on here. I'm going to go ahead and turn that spun outline off so we don't have to see that anymore. And let's create some milling operations. I'm going to do a couple of things here, I think. We have these mill methods as well. Again, we can rough it and leave stock on it automatically. So I'll do that. I'm going to rough it out and I'm going to leave stock with this operation. I could do this I could rough it and finish it with one operation, but there's a method to my madness here. I'm going to do something with the other operation for my finishing, just to show you a little bit more functionality. So this is the only reason I'm going to go ahead and do it with two operations instead. So this is my depth of cut. I'm going to take 10 millimeter depth of cuts, and I'm just going to select some geometry. So I'm going to specify what I want to cut. And we have these little face rules that are very helpful. You can say, I could click each individual single face, but I could use these face rules and say, I want all the tangent faces to this one. So as I select this face, it'll just grab all those faces on that hex since there's corner radiuses on there. I'll grab that face too. So I grab those faces and I go ahead and generate that. There's my tool path running around. Real nice tool path. It's got our tool there, leaving stock here, leaving stock on the bottom. We can see all that there. All right, if you want, you can verify this and just run the tool through as well, just to see how it's looking for you. All right, we can watch that tool. This isn't the actual machine. This is just verifying the tool path itself. That's the only thing it's doing here. But we'll run the entire machine simulation and see the machine moving here shortly. All right, for my next operation, I'm going to finish this hex, and at the end of it, I'll show you why I'm doing it with two operations here. So I'll use another operation type altogether just to show a little bit more functionality there. So I'll do a finishing operation. So this is a different one. This is just a profiling a wall and a floor, for example. So we can name our operations. I kind of have a bad habit of not doing that, but this will be finish hex. So this one, we're going to finish the hex with this operation. What we're going to do with this one is we're going to tell it the floor. What's our floor right here? Now this has a checkbox for automatic walls. I can select this automatic walls. I could select them myself, but I can use this checkbox and I can look at the walls that it selected for me. And if it selected them right, you know, that saved me a couple of clicks. Looks like it did select all the walls correctly. So all that's good to go. I can just go ahead and generate that. There we go, we've got a good toolpath there. Now the reason I wanted to do this with two different operations is this first operation, the Z-level profile and the finish hex that we've got here, I'm going to do something with this finish hex. The Z-level profile is going to take the tool with the upper head and move in X and Y, where this one, I want it to use the C axis to move instead. So I want it to do more of a polar type of a move. So I can come in here to what we call user-defined events, and I can just simply lock the Y-axis out. So it won't move the Y-axis to cut this hex, so the only way that the kinematics can work to do that is to rotate the C-axis to do that instead. So we'll run that instead. So we'll look at that when we run the simulation as well. So we've got that milled out. The next thing we're going to do is, I'm going to use the same tool to cut this pocket, but I want to use those, I want to utilize showing you sync marks. So I'm going to go ahead and drill first, and then I'll come back and cut that pocket. So let's go ahead and create a drilling operation now with our drilling tool. So here we're going to specify the features that we're going to drill out, and we're just going to select these holes here along the outside, and it's going to preview in this translucent, transparent kind of a pink preview of what it's drilling out for us here, based on that geometry. I mean, this is just a dumb solid, but it'll recognize the feature. It's got the feature recognition built in to where it'll know what to drill and how deep and all those good things. I don't really have to tell it a whole lot. There's 5, and I got one more at the top here. 6. Okay, so there's all 6 holes. I can look at all 6 of them, preview what it's going to drill out there. I'm also going to set up some, how it's going to come off of that part. I'll set some feeds and speeds on it as well. This is where you would put feeds and speeds. I didn't do this for the other ones, but surface meters per minute, feed per tooth, whatever those might be, you can just set those pretty quick and you can generate that. So there's our drilling operations, just drilling those 6 holes around the outside. All right, finally we'll do the pocket here. We're going to mill that pocket, and we're going to go back up to, we've got a very simple pocket milling type operation that will finish this pocket. Again, this one, very easy. I'm just going to specify the floor, and those automatic walls are going to take care of the rest. I can just generate it, and that'll determine where the stock is, the current condition of the part, the raw stock. It's going to helix into the center and work its way out to the outer walls. All right, so there's our completed program. The last thing I want to do before I go into the Sync Manager is I want to see this part actually spinning with the kinematics of the machine, not just in the verification. So we just set that up real quick here in this kinematics setup here. We just define the part, just quick and easy. That's all it takes. You just have to link that up. That's all. And now we can look at the Sync Manager. So, we've got all of our tools set up. Double check them here real quick here. That looks good. Our upper head tools, good. Just double checking some stuff here. Yep, those are all lined up good. We'll put some sync marks into this now. So let's take a look at that. We're going to go to our main program, and we're going to go into our synchronization here. So like I said, those sync marks automatically are put in for the pinch turning, and we're going to see those here. This is going to link up to the post processor embedded into this simulation kit. So it uses its own post processor. We'll actually be running posted code through this simulation. So you see in green, all these sync marks are already put in here for the pinch turning portion. So it's going to do all these sync marks. So this is channel 1 over here and channel 2 over here. All right, so channel 1, by the way, is the upper head. Channel 2 is the lower turret. So then towards the bottom, you can see these other operations here. So when it finishes the rough turning, it's just a free-for-all for the rest. So I'm going to go ahead and enter in some other sync marks in here. I'm going to insert a sync event in channel 1 and 2. So we just put those in, and then you drag the sync marks wherever you want. You just drag and drop them. So I don't want to do the drilling while I'm doing the finished turning, right? The spindle's going to be moving. So I'm just going to drag this sync mark from this side above the drilling. So now it's going to finish doing all the rough turning, finish turn, Z-level profile the hex, finish the hex, and then it's going to go over to do drilling and pocketing. So I probably need to do another sync mark in there as well. So we'll add one more sync mark in here, and we'll put this one below drilling on this side. So you see it's going to do all the channel 1 stuff for the hex, then it's going to come and drill, and then it's going to go back and do the pocketing. Okay, so that's the sync marks. We'll reset that machine to regenerate the code. You can see the sync marks. It'll regenerate those and put those in the right places in those new ones that we added. So it's going to run this actual NC code through this simulation process. All right, we're showing 3D material removal. However, you don't necessarily have to show that, but you can. You can show it. I like to show it removing the material. We can do some different settings throughout here. We can make that material removal a little bit translucent if we want to see the part inside of it. So we could do all those things as well. So let's go ahead and play this and see what it looks like. So we see both of our channels moving at the same time in our simulation. We're switching tools. Channel 2, our lower turret, is going to go ahead and come down here and position and wait for its sync mark here before it starts actually turning anything. Because remember, we got to face it first with this upper head. Speed this up a little bit. So you see that it rotated to that 90 that I defined. I kept defining that to 90 degrees, and there's that 90-degree rotation for the upper head. So now this is going to go ahead and face it off, and you see this guy is sitting here waiting for its turn to run. Now it's going to go ahead and take off together, do its pinch turning together, and you can actually see the that 3mm lead here. Sort of hard with that translucent display, but I think you can see it. Yeah, there it's a little better. You can see that 3mm lead from the top one to the bottom one. All right, I'll speed this up a little bit. And as it gets finished with roughing this part, now the lower turret's going to go ahead and park its way over back where it belongs, and the upper turret's going to go ahead and change tools and continue on finishing this part out. Now it's going to grab our end mill. Now we're going to see the X and Y movement here with the upper head as it's roughing this. And then on the very next operation, it's going to use just the C-axis. Remember, I locked the Y-axis with that second, the finish operation here. So this is using X, Y, and Z. Now it's going to use X, C, and Z here. So there's that toolpath running with the C-axis instead. So now it's going to go ahead and go to that lower turret for the drilling. And we're going to go ahead and drill these holes now. All right, so it does all that, and now it's going to take this tool once again, rotate it to run this pocket. So in the simulation settings here is where you can set your collision checking. Check for collisions for your tool and part, IPW, machine collisions, all those things you can set up right in here. You can just turn them on. So the next thing I wanted to show is how quick and easy NX can update tool paths if a model's been changed. So let me go and save this here. And I'm going to go back to that master model that I talked about at the very beginning. This is on a different file, so I'm going to take my cam hat off for a second. I'm going to put my CAD hat on, or maybe even the customer gave you an updated model. So as I make changes to this as a design team or a customer, I'll just make a couple of quick little changes to this here. Let's move this, move that back. So these are the synchronous modeling tools that are available to us that we can quickly change. This is actually changing the topology of the part too. These are great, easy tools to use to manipulate the model. Let's change this to, yeah, we'll just make some subtle changes like that definitely change the part, right? So our tool paths, when I go back, let me save this, come back to our part here, we can see that those changes did automatically update to our cam part, but our tool paths are out of date. Now in a lot of other softwares, what do you have to do? You're going to have to redo all of your tool paths. You're going to have to reselect all your geometry, reestablish everything. For me, I'm just going to grab the top parent and just regenerate all the operations, and it's going to, all the associativity built inside of NX between all of the different applications, it's just going to take care of itself. And we can look through the updated tool paths here, and we can see where it's roughed out to the right sizes and depths. Here, the finished turning is cutting to the right spots. Our Z levels cutting to the right depth again. Our hex is cutting to the right depth again. All those changes made are updated really nice and easy. Thank you for attending our webinar. Please let us know if we can assist in any way.